Alrighty, so for today's lesson, we are going to deal with locus again, but now we're actually going to find equations of lines and do stuff on the graph. So on the first one, it wants you to write the equation for the locus of points equally distant from the lines y equals 2x plus 3 and y equals 2x minus 7. So go ahead and graph both of those lines. The first one, remember the y-intercept is positive 3, and then to find the slope, you're going to go up 2 over 1. I'm not oriented very well, as you can see, so just make sure when you graph yours that you're actually getting it much better than mine. So I'm going to take this line right here and I'm going to label it. I've got more than one line on the plane, so I want to label it. The second line is 2x minus 7. So I'm going to begin down here at negative 7. And again, I'm going to go up 2 over 1. These lines have to be parallel because they have the same slopes. So I'm going to graph this line right here. And then I'm also going to label this. This one was y equals 2x minus 7. So if we want to find the locus of points equally distant from these two given lines, we know it has to be one line that's parallel to and halfway between what's given. So if it's parallel to, we know the equation is going to have to be y equals 2x. But then we need to figure out what the halfway between part is. So in this case, you can really look at your y-intercepts. So the first y-intercept was at positive 3. The second one is at negative 7. So if we wanted to be halfway between 3 and negative 7, we're going to end up being negative 4 over 2, or a y-intercept of negative 2. So the equation of the line in this case would be y equals, so we have to be parallel to, that's why we've got the same slope, and the y-intercept is going to be down at negative 2. So if you graph this particular line, begin at negative 2, up to over 1. Again, I'm not oriented at all, so you need to make sure that you're drawing yours much better than mine. You'd probably just orient this thing and be fine, but then here is not only the line, but also the equation of the line. So this becomes y equals 2x minus 2. Okay, so we pretty much have already done stuff like this. Okay, so now we take a look at the next one. Next one says is write the equation for the locus of points equally distant from points A, which is 0, 0, and B, which is 4, 4. So the idea is we need to find the equation again of the perpendicular bisector, because if we find A here at 0, 0 and B over at 4, 4, then the locus of points equally distant from these 2 points, think about what we did yesterday. If we were to kind of connect these 2 points together, then what we would need to do is find the perpendicular bisector of those 2 points, and that would be the equation that we want, or the line that we want. So in order to do that, the first thing we have to do is find the midpoint of those 2 points. So if we look for the midpoint, we're going to get 0 plus 4 over 2, 0 plus 4 over 2. Midpoint ends up becoming 2, 2. If we find the slope, given those 2 original points A and B, then we're going to do 4 minus 0 over 4 minus 0, which is 4 over 4, which is 1. If we find the slope of a line that's perpendicular to the one that has a slope of 1, we know the perpendicular slope is negative 1. And then lastly, we're going to do the equation of the line. I remember I do the point slope form, so I'm going to use this particular midpoint and this particular slope, and I'm going to say y minus 2 equals m x minus 2. I'm going to bring this down just a tad and bring it up, I guess. Come on. Here we go. So this becomes y minus 2 equals negative 1x plus 2. Add 2 to both sides. And the equation of the line, that's the perpendicular bisector of line of points A and B, is y equals negative 1x plus 4. So what I want to actually do is graph that. So if I take this particular line, go back up, and I'm looking at y equals negative 1x plus 4, this should be the perpendicular bisector of these 2 points. So if I begin at 4, and I go down 1 over 1, down 1 over 1, and I connect these dots, right here, this particular equation makes a right angle with the segment that connects those 2 points. It makes those 2 sides of that line segment congruent. Okay? Just got 2 more to go. This one says, write the equation of points. I think this is the one that I skipped. Hold on. I think this is the next one for you guys. Yep, I think this is the next one. So write the equation for the locus of points whose distance from 4 comma negative 2 is 3. So again, they're giving you a single point. So if the single point is 4 comma negative 2, and if you want to be 3 away from that, go back to locus where you're really just dealing with a circle. 1, 2, 3, 1, 2, 3. I'm going to go ahead and try and draw this circle. Let's see if I can get this circle drawn. I start here and kind of go out. Not great, but that's the circle that you're looking for. And then don't forget equations of circles. Standard form x minus h squared plus y minus k squared equals r squared. So given our center being 4, negative 2, it's going to be x minus 4 squared plus y plus 2 squared equals r squared. So I believe this is your number 3. Okay, we've done that plenty. And then last but not least, I believe is going to be this one. Write the equation of the locus of points equally distant from the lines x equals negative 2 and y equals 4. So if we graph this vertical line first, here at x equals negative 2, it doesn't look like it's at negative 2. Hold on, let me try this again. Let me cut this out. Oh, really? Cut. Cut. Okay, let me try this. Oh. What's going on here? This is making me mad. Hold on. I'm going to pause this. Okay, I'm back. Let's try this again. So if I go to x equals negative 2, that looks better. And then we go to y equals 4. That's not up enough. I'm going to drop this down a little bit and see if I can. How's that? That looks good. Okay, so then we've got... So the idea is we're really looking for the angle bisectors of this parallel and perpendicular, of these perpendicular lines, where the origin is no longer a center, but the center is going to be at this point that's right over here. So basically, if this is where I begin my line, it's like kind of saying like the y equals x line if we wanted to use the x and y axis as our 2 lines that we wanted to be equally distant from. So we know that we want to have this kind of be our, I guess, our starting point, and then our first slope would be positive 1, so up 1 over 1. Hopefully you're following me because I'm getting a little tongue-tied here. Boom. So we're looking for this particular line right here, and then we're looking for starting at the same place, but now our slope being down 1 to the right 1. And then we're looking for this particular line. And then we want to write the equations of both of those lines. So in this case, what's happening here is when we take a look at for our y-intercepts, this first one, the positive slope, has a y-intercept really of 6 up here. So we're looking at it, it's kind of hard to tell. It's probably easier on yours. But here's really where my y-intercept is, which is up at 6. And then in terms of going from point to point, it's going to be up 1 over 1. So this top line right here is going to be y equals 1x plus 6. This other line, the one that's got the negative slope, what's happening here, it looks like the y-intercept is supposed to be here at positive 2, but then you're going down 1 over 1. So this would be negative 1x plus 2. So those would be the equations of those 2 particular lines that are equally distant from x equals negative 2 and y equals 4. It's going to be this guy here and this guy here. All right, so that is it for, and this should be number 4. That is it for what we're doing for today. Your homework is really not about this. The homework is going to be really based on some review from this first few units, so probably really the first 11 units, okay? So good luck, and see you tomorrow.